your audiences for being here, taking your time out of your hectic schedule to learn, unlearn, and relearn something, and update yourself with the new trends in the market. To begin with, let me take you back to late 80s or early 90s, when the core means of communication was postal services. It was that era when people used inland letters or envelopes or postcards, or sending messages from one state to another state, from one city to another city, from one town to another town, and from one district to another district. Thank you. And during that era, there was a challenge for reaching the message from the recipient or from the sender to the recipient. It almost took 6 to 7 days time, right? And the most fastest means of communication that was known to the people was telegraph services, and it also took almost 12 to 24 hours during that. And now the time has changed, and now we are blessed with the upgraded technologies like WhatsApp, emails. By just only a single click, we are able to send messages from one corner of the world to another corner of the world, right? Within a fraction of a second. How this transformation, how this 360-degree transformation has happened? Can anyone please tell me? कोई आप में से कोई बता सकता है? Digital. Anybody else? Internet, that I have already covered. Anything else? This 360-degree transformation happened because of only three front lines. Number one, innovation, right? Number two, awareness. Number three, acceptance. Right? With this perspective, today I am going to throw light and discuss about one of the obvious challenges that we HVAC professionals encounter every day in HVAC sector. Particularly when we talk about water cooled chillers and heat pumps, and that obvious challenge is nothing else other than condenser fault. Now, a question may strike your mind. Just a few moments back, you spoke about the challenges in the communication sector, and now you are talking about the challenges in the HVAC sector. How both are related to each other, right? That question may be striking your mind. Good, I am going to settle your queries. Just a few moments back, what did I tell you? That there were three frontliners which played a pivotal role in bringing a transformation in communication sector. And these three frontliners can help us to evade this obvious challenge, that is condenser fault. Number one, innovation. That technology is already invented, that is available in the market. Number two, awareness. Why I am here, sir? Why I am here? To create that awareness, right? To enlighten you people with that technology. Number three, acceptance. Who has to accept it? You people. Why? You have to embrace the change, because the change is in the air, the change is in the water, the change is in the fire, the change is in the sky, the change is in everything, in all the 5 elements of life. So move forward and embrace the change, right? So when we talk about condenser fouling, what do you understand by condenser fouling? In simple words, if you ask me, I can tell you one thing. Condenser fouling is the accumulation or the deposition of mud, silt, mud on the internal surface of the condenser tubes. It will scale formation also. How it is formed? It is formed predominantly by the mineral salts that are present in the water. And a few moments back, or 1 or 2 hours back, the researcher has thrown light on it that it's because of heat exchange and evaporation. That's the reason why the scale formation happens on the condenser side, right? And what are the mineral salts that are available in the water? They are CaCO3, MgCO3, SiO2, Fe2O3, pH of water. Though we are not water chemistry experts, so let's not go into the nitty-gritty of it. Okay? Now, the question is that if condenser fouling is a challenge, if it is so nefarious, then how can it be so nefarious? Right? What are the ill effects of condenser fouling? The first is that it acts as a barrier. It acts as a barrier to heat exchange. In vapor compression cycle, particularly when I talk about vapor compression cycle, what happens in the condenser cycle? The heat is dissipated from the refrigerant to the water. Am I right? If suppose if your condenser tubes are poured from inside, what will happen? The restriction will happen, right? The heat from the refrigerant won't get transferred to the water properly. Then what will the effect? The entire vapor compression cycle will get disturbed. With that, what will the outcome? We will have a compromised cooling effect, right? This is one part. What is the second part? Second part is that with the accumulation of the deposition of the scales in the internal surface of the condenser tubes, what happens? They get blocked, and because of that, they offer resistance to the flow of water, right? With the blockage of the condenser tubes, when the resistance is offered to the flow of water, what will happen? The condenser pump has to exert more pressure. It has to work more harder to push that water. And when it does, what it will do? It will exert more energy. The more power it will exert, the more energy it will drop. So it will have dual effect. It will have dual effect. One is that there will be a compromised cooling effect. Number two, it also affects the energy efficiency, right? So this is the relationship between the chiller efficiency and the condenser fouling. Chiller efficiency is inversely, it has got an inverse relationship with the condenser fouling. The more the condenser fouling, the lesser will be the chiller efficiency. Got the point? The more the condenser fouling, the lesser will be the chiller efficiency. And the more, if you want to elevate the chiller efficiency, what you have to do? You have to pull down this condenser fouling from this level to this level. Okay. Now we have realized, we have understood what is the challenge. These are not notional figures. These are the studied and these are proven figures. Studies reveal that for every 0.6 mm of thick scale, there is a drawback of 20% of energy efficiency. 1 mm condenser fouling translates to 36% increased power consumption. See how nefarious it is. If I say 0.1 mm of condenser fouling, 0.1 mm of condenser fouling translates to 1 degree centigrade increase in the condenser approach. Will you agree to that? Will any one of you agree to that? I need your answer, sir. Are you getting my point or not? Or simply I am simply moving my lips and people are enjoying? Can anyone give me the answer, please? 1 degree centigrade increase in the condenser approach results to 2.4% to 3.6% energy losses or shortshifts. That means if I consider 3% on an average, 1 degree centigrade increase in the condenser approach will lead to 3% energy loss. Then imagine 6 degree centigrade. 6 degree centigrade increase in the condenser approach means how much? 0.6 mm of thick scale is formed in the condenser tubes. That leads to how much? 18%. So in the previous slide, what I have told you, 0.6 mm thick scale translates to 20% of energy losses, which is quite closer to it. There are other factors that are responsible for that, which I have not covered in this slide. Let's study the life cycle costing. What do you understand by life cycle costing? When you invest something on a capital equipment, right? And when we talk about HVAC systems, hardly any end user invests 10% on it and 5% on its maintenance. Am I right, sir? Give me some, am I right? And 85% of the energy cost, they want to drain it off. Willingly and happily, customers drain the money in the form of operating cost. 85% of it. If suppose if I buy a chiller, मैं एक चिलर खरीदता हूँ 10 लाख रुपए में, इसको आम भाषा में आपको समझाने की कोशिश करता हूँ। 10 लाख रुपए का एक चिलर खरीदता हूँ और उसका लाइफ साइकिल जो है 12 साल, मान लीजिए 12 साल उसका लाइफ साइकिल है, ठीक है? और 5 लाख रुपया उसका पूरे उसके जीवन काल में उसके मेंटेनेंस के पीछे का 5%, यानी कितना 5 लाख रुपये उसके ऊपर इन्वेस्टमेंट कर रहा हूँ, तो कितना आपका पैसा कमाने वाला हूँ मैं ऑपरेटिंग कॉस्ट के पीछे? हिंदी भी समझ में आ रही है? कितनी आ रही है सर? कितना कितना कमाने वाला हूँ? 85 लाख। सर आप मेरे तरफ देखने वाले स्लाइड की तरफ देखिए, आपको जो फिगर है एकदम क्लीन कट आपको दिखेंगे। 10 लाख रुपए का इक्विपमेंट मैंने खरीदा, 5 लाख रुपए उसको मेंटेनेंस के पीछे खर्चा किया, और 85 लाख रुपए जो है 81% आई हैव वेस्टेड इन द फॉर्म ऑफ ऑपरेटिंग कॉस्ट। टोटल कंट्रीब्यूटिंग टू हाउ मच? कितना होगा फिगर? 1 करोड़। एक होगा मुंबई लैंग्वेज में, एक होगा बोलते हैं, ठीक है? इस एक होगे को जो है मैं इसको रिड्यूस करके 80 लाख तक लेके आ सकता हूं। हाउ कम? सपोज इफ आई इंक्रीज दिस कैपिटल कॉस्ट ऑफ द इक्विपमेंट फ्रॉम 10% to 20% by integrating with upgraded technologies. Number 1, spending more on maintenance cost. 5% की जगह मैं 10% करता हूं, तो ये मान लीजिए कि अगर मान लीजिए कि मैं 10 लाख रुपए के इक्विपमेंट के बजाय 20 लाख रुपया उसको अगर इन्वेस्टमेंट करता हूं और 10 लाख रुपया जो है मेंटेनेंस कॉस्ट में इन्वेस्टमेंट करता हूं, तो ये पूरा ड्रॉप डाउन होकर कितना हो जाएगा? 50 लाख पे आ जाएगा आपका ऑपरेटिंग कॉस्ट। टोटल पे आपका कितना सेविंग हुआ? 20 लाख। एग्री करते हैं आप? 20 लाख रुपया इक्विपमेंट के पीछे खर्चा किया, 10 लाख रुपया मेंटेनेंस के पीछे खर्चा किया, और ऑपरेटिंग कॉस्ट 50 लाख। कितना हो गया? 80 लाख। Which is more economical? इक्विपमेंट कॉस्ट के ऊपर मैं अगर 20 लाख रुपए खर्चा करूं, सर कैपिटल कॉस्ट को कैपिटल इक्विपमेंट के पीछे अगर 20 लाख रुपए खर्चा करूं और मेंटेनेंस के पीछे 10 लाख खर्चा करूं, तो ओवरऑल जो है मेरा खर्चा कितना बच रहा है? इतना खर्चा करने के बावजूद मेरा 20 लाख रुपए बच रहा है। Got it? Now let's talk how to remove this condenser fouling. हमें अभी तक समझ में आ गया condenser fouling is nefarious, it's a disaster to HVAC systems. So far we have learned that, right? Now what are the means to remove the disconnect? In the territories of either Chhattisgarh and MP, particularly I'm not against any particular territory or any region. Please don't get me wrong, don't misunderstand me. I'm not against anybody, but I'm discussing about, I'm revealing the fact, and it's an undeniable fact. One has to accept it. In the territories of either Chhattisgarh and MP, either Chhattisgarh and MP, you will find that people prefer to go with manual descaling. Right? What is manual descaling? Manual descaling is a process that involves the circulation of a solution of water mixed with a chemical multiple times, then draining of the solution followed by mechanical brushing, then afterwards flushing all the condenser tubes with fresh water, so that whatever the remains are there, they will be washed out. This is manual descaling. ठीक है? Simple. Got it? So far what we have realized, there is a problem, and what is the problem? That is condenser fouling. There is a solution to it. What is that solution? That solution is nothing but manual descaling, right? Unfortunately, this manual descaling, this solution, it comes with multiple problems. How come? Let me throw light on it. Manual descaling is expensive. Why it is expensive? It needs a lot of logistics. Unfortunately, people don't realize it. Second thing, safety precautions. This is the most gray area which anybody focuses on it. Okay? Third, manpower. When we talk about manpower, I am sorry to say I am really harsh in saying that we have to accept the truth and the fact that in the territories of Bihar, Chhattisgarh and MP, you won't get skilled manpower. Apologies if I am hurting anybody's sentiments. Second, when we say that we use chemicals in the process of descaling, manual descaling, particularly when I talk about manual descaling, then what is that chemical? That chemical is nothing but inorganic acid based product, which erodes the metallic surface of the condenser tubes. When this metallic erosion happens, what will happen? It weakens the condenser tubes. Ultimately, what are the end results? The end result is nothing but it's a compromised life. It's a compromised life cycle of the equipment. जिस equipment के थोड़ी देर पहले दिनेश साहब ने एक अच्छी बात बोली थी, कोई भी equipment हो in general, irrespective of its make, brand or anything, am I right sir? Irrespective of its make, brand or anything, एक आम तौर पे एक औसतन उसकी जो एज होती है, उसकी जो आयु जो होती है, वो होती है 15 साल. when we compromise on the thickness of the condenser tubes, that means what? 15 साल से उतर के अगर 10 साल चिल्लर चला तो कितने बड़े लॉस में हुआ? Can you ever imagine? Imagine कर सकते हो आप? Third, manual descaling that involves long shutdowns, which may affect your building operation. अगर एक होटल में अगर आप शटडाउन ले रहे हो तो बट ऑब्वियस आप अपने गेस्ट को तकलीफ दे रहे हो, या तो फिर आप होटल का बुकिंग बंद कर दोगे, उससे कितना लॉस हो रहा है सर? हैव यू एवर गिवन अ थॉट टू इट? अनफॉर्चुनेटली नोबडी डज दैट. अ लॉट ऑफ वाटर वेस्टेजेस. क्या पानी जो है हमारे पास पर्याप्त मात्रा में है? ये मत बोलिए नागपुर में बहुत सारा पानी है, 3-4 दिन पहले पूरा पूरा शहर डूब गया, ये मत बोलिए. डोंट से दैट. नेक्स्ट, risk of either tube damage or else abrasions. Means what? मैंने अभी थोड़ी देर पहले आप सब लोगों के सामने एक बात रखी थी. Unfortunately, we don't have skilled manpower in this area. That means what? जहाँ पे लोग सोचते हैं अरे कंडेंसर इसके लिए क्या रखा है, और किसी को उठा के लेके आएगा, ब्रश ऐसे 2-4 बार मारने का हो जाएगा. अगर एक आम आदमी भी एक अनस्किल्ड टेक्नीशियन भी काम कर सकता है, तो फिर आप ये मान के चलिए कि आप अपना 30 लाख रुपया, 40 लाख रुपया, 50 लाख रुपये का इक्विपमेंट जो है उसके हवाले कर दे रहे हैं कि बाबा किसको खिलौने के जैसे खेती करें. इट्स एज सिंपल एज दैट. This is a video clip. I have tried to capture some of the events that happened during the process of manual descaling. Please have a look. So, what is the way out? हमने सबसे पहले क्या जाना है? There is a problem. That problem is condenser problem. Then we have realized a solution to it, and then afterwards we realized another thing, that solution comes with multiple problems. Then there has to be some way out. No, if there is no solution to a problem, that problem is going to remain as it is. But there is a solution to it, and that solution is nothing but I can say that it's here. It's a blessing in disguise. It's a blessing in disguise. It consists of one valve, a set of or a pair of pumps for election and for injection. Valve collector, valve trap, control panel, solenoid valves. Here I have mentioned electrically operated control valve is solenoid valves. And next, necessary fittings and valves. जब आप पाइपिंग करते हो तो आपको fittings valves और सबको लगता ही है. How does this system function? As I told you, it consists of sponge valves. Electric sponge valve कहते हैं, but the embossing of the valves is unknown to anyone because it's a patented product. These sponge valves, they are first of all injected into the condenser tubes, and when these sponge valves pass through the condenser tubes, what happens? It keeps cleaning the condenser tubes, right? And the valves are then collected at the boiler. During the next cycle, that is the collection cycle, what happens? These balls are again pulled back to the ball collector, and rest of the water is what? Is drained back into the condenser outlet pump. The entire process is a batch operation. Means the cycles can be repeated 2 times, 3 times, 4 times as per the desire of the end user. This is the presentation of the chemical presentation of the injection cycle. Here you will find the first pump, the top one pump. That is the injection cycle. During the injection cycle, what happens? The other pump, the collection pump, that will be deactivated, and this pump will be activated. It will suck some water. It will take some water from the condenser inlet line, push the pressure so that the valves present in the collector, they will be pushed into the condenser tubes. Right? Since this is a two-pass condenser, all the valves will return back to the outlet of the condenser and get collected at the ball line. This is the completion of the injection cycle. Now, coming to the collection cycle. During the collection cycle, what happens? The injection pump that gets deactivated, and the collection pump that gets activated. During the collection cycle, the water is sucked from the ball trap, so that all the balls that are collected in the ball trap, they will be able to return back to the ball collector, and rest of the water will be pumped into the condenser outlet line. Here there are no ball losses, no water losses. It's a common working system, and there is no water wastage involved in it. Without any, this is the condition of the condenser tubes. आप में से यहाँ पे जितने लोग मौजूद हैं, कितने लोगों ने चिकन प्लांट में काम किया? थैंक यू वेरी मच सर, थैंक यू वेरी मच सर, मेरी इज्जत रख ली आप लोगों ने। वरना तो मैं भी यही सोचता था कि बिना मतलब मैं लोगों के सामने बड़बड़ कर रहा हूँ, इसको समझ में नहीं आ रहा। सिंह साहब आपका तो इतने सालों का एक्सपीरियंस है इसमें, और धीमे साहब के बारे में क्या कहना है? Even धीमे साहब, honestly telling you, he's my guru, he's my mentor. Under his leadership only I was doing that. When I was in Gujarat, we were 20 years, right sir? This is the effect of ATCS on condenser tubes. जब आप कंडेंसर ट्यूब्स में जब आप नए सिस्टम में जब लगाते हो, सालों साल 10 साल के बाद जब आप उसको एंड में खोल के देखेंगे, तो you will find this kind of scenario. So what are the overall benefits of using a ATCS automated tube cooling system? Number one, increased cooling capacity. How come? थोड़ी देर पहले मैंने आप लोगों को क्या बताया? कंडेंसर में क्या होता है? कंडेंसेशन होता है। अगर मान लीजिए कि कंडेंसर ट्यूब में अगर फॉलिंग हो गई तो क्या होगा? कंडेंसेशन प्रॉपर नहीं होगा, जिसकी वजह से क्या होगा? आपका जो है कूलिंग इफेक्ट मारता है, राइट? एफिशिएंसी ड्रॉप हो जाएगी। यहाँ पे क्या हो रहा है? When the condenser tubes are clean, what will happen? Ultimately, the vapor compression cycle will function excellent, right? Number two, increased tube life. How can you edit increased tube life? Because you are not using any chemicals here. There is no manual intervention here. So ultimately, the life of the tube that can be retained. ठीक है? Up to 20% savings. मैंने आपको पहले क्या बताया? 0.6 mm 6K. Translation 20% energy process. It can be even more than that. It can be even more than that. लेकिन आमतौर पे जो देखा गया उसके बारे में बताया। तो यहाँ पे बच गया आपका efficient cooling, long life, less maintenance. बराबर है? Enhances efficiency, eco-friendly. Eco-friendly है क्या? वो chemicals यूज नहीं कर रहा है, कोई refrigerant यूज नहीं कर रहा है. It is obvious that it will be eco-friendly. ठीक है? It avoids, it completely eliminates the wasteful shutdowns. जब आप मैनुअल स्केलिंग करते हैं, तो आपको जो 2 दिन के पहले से आपको प्रिपरेशन करना पड़ता है उसके शटडाउन के लिए। यहाँ पे आपको शटडाउन की कोई जरूरत है सर? There is no need of any kind of shutdown because it's an online process. You are not using any chemicals. So the thickness of the tubes that will remain as it is only. This system offers you the flexibility to run in dash operation for 2 or 3 seconds or 3 to 4 seconds. Depends on end user's desire. The beauty of this technology, the beauty of this product, or the beauty of this technology is that single unit can be coupled and integrated to multiple chillers or multiple condenser units. That is the beauty of this technology. Zero ball loss. मैंने आपको पहले ही बता चुका है, उसका इंजेक्शन साइकिल और कलेक्शन साइकिल मैंने आपको बता दिया है. So how it functions? So there is hardly any chance, there is no chance. That I must say, precisely speaking, there is no chance of ball losses. And the beauty of this product is that its ROI is as less as 2 years, even less than 2 years. To be on the safer side, I have considered 2 years. Whatever the investment that you make, that can be retained back within 1 to 1.5 years. जब आपको इतने सारे फायदे दे रहा है, तो सीधी सी बात है, आपको तो फायदा हो ही रहा है ना. So let me outline the benefits that we have discussed so far. Results of 20% energy savings in water-cooled chillers and heat pumps. Increased cooling capacity कैसे होता है? When there is no current flowing, ultimately there won't be any compromised cooling effect. Improves condenser life because you are not using any there is no manual intervention in that. There is no manual scaling, no manual brushing involved in it. You are not using any chemicals in it. Improves compressor life. That means what? With the increase in the approach, ultimately the discharge pressure is going to increase. That is going to affect your compressor bearings and all. So यहाँ पे जो है, with everything, when all the parameters are normalized, what will happen? Compressor life will be increased, right? Avoids costly shutdowns. जैसे मैंने आपको बता दिया, इसमें shutdown नहीं किया हमने, totally online process. Elements often will be completely covered in that. Avoids harmful chemicals that are used for descaling. इसमें कोई chemicals use करते ही नहीं है. Cost-effective technology as it offers very attractive ROI, even less than 24 months. 24 months मतलब कितना होता है? तो मुझे बता सकते हैं? सिंपल, लेकिन मुझे ऐसा लगा कि मुझे आप लोगों को जगाना चाहिए. What are the key features of automated cooling system? Single system can be coupled to multiple chillers or heat exchangers. It is fully automatic. No manual intervention is required. Once you program it, खलास, forget it, चलता रहेगा वो. And for the chiller that doesn't work or function or which is under shutdown, the system won't operate. The cycles won't function from that particular group. No water exchanges. Online cleaning on continuous basis. Zero ball loss. Ensures 100% green juice. And it is a smart system. Why we call it a smart system? The moment when it detects the balls, now the life cycle of the balls is over and they need to be replaced, and alarm will be generated. That's great. My dear. That's all for now. Before I wrap it up, let me make it clear to you a small investment made on this technology. A small investment made on this technology will help you to return you back in multiples. So don't miss the boat. Don't miss the boat. It won't cost you an arm and a leg. This is ISHRAE signing out.